Hi guys, welcome Mindsetters. Today we have life science, and as you can see, you guys out there that have been watching, we have the famous Kathy.
Oh, whoa.
No, it's true. It's
Hi
true.
everybody.
All of you guys have been watching and have watched previous live shows. Kathy is fantastic, and if you want to know everything in life science, you better be joining in.
She's giving me a big head, everybody, really. But it's wonderful to have all of you with us. I know grade 12 can be very daunting. Yeah. Can you remember what it was like to go into matric, hey? Because last year we all
have nightmares about it.
But we all thought we were like the big fish, and you were the big fish, and then the first week of school, and you thought, whoa, this is a lot of work. And halfway through the year, it was, oh my gosh, half our year's finished. We've got another 3 months of school, and then we're done.
Exactly.
So it goes very quickly.
But this is grade 10 now, but what...
Oh, yeah, of course, it's grade 10.
But it still applies, because what I think
now they're in big school.
Yeah, and if they really concentrate now, from grade 10, 11 and 12, matric should be nothing. It should be plain sailing, there should be no stress, it should be calm. So guys, we're going to take a short break. Please, please, please join in on the discussions on Facebook, Facebook/LearnExtra, that's with an XTRA. Also at Learn Extra for Twitter.
I'll write it down for you as soon as we come back after a little short. I think we're going to have a little short break.
Yeah, but you see how helpful she is. She's fantastic. Do you want to tell them quickly before we go to break what we're going to be talking about?
People, it's on the screen. It's chemistry of life. We're going to be talking about all the little bits and pieces that make up who you are and why diet is so important. So, and you know what? Grade 10 forms the basis of every other grade. So work hard in grade 10. You can maybe cruise a little bit in grade 11, and then you have to work very hard in grade 12. But you need to put in the effort, and it's going to be easy. We're going to take you through it step by step. Indiana and myself, all right?
Fantastic. So see you after the break, and don't leave those seats. Hi guys, welcome back to grade 10 Life Sciences, and we are so excited. We're going to have such an incredible lesson today. What do you guys think of our new set? I know I keep saying it, but let me know on Facebook. Tell us what you think. Give us suggestions. Give us questions. Just pop in and say hello. We don't mind. Whatever. We want to chat to you, and we want to get the show going. So Kathy, what have we got for today?
Hi boys and girls, and I can call you boys and girls because you are young ladies and young gentlemen, and this is the beginning of your FET phase. Now, FET means further education and training. So you are now going into the last 3 years of your school career. You've been at school now for 9 years. That's a long time, hey? 9 years? Well, now you are stepping into that last 3-year area or process. And everything you do now, people, is going to form a foundation and the grounding for grade 11 and grade 12. Now, you know that if you build a house and the foundations are not good, that whole house is just going to go and fall away. We have to focus on your grounding. All right, so now we're going to start with chemistry of life. And if we look at the chemistry of life, at the end of the day, we start off with various, I want to put a blank sheet of paper in here. We start off with the basics of life. Now, if we look at the basics of life, let me just, hang on, this is all touch screen and this is all very, very new to me, so you're going to have to just help me a little bit here. Okay, if we look at the basics of life, we say that everything on this planet is divided into,
don't worry, there are gremlins in there.
Organic and inorganic substances. I'm just going to put sub here. All right, now, organic and inorganic. Let's see if we can, there we go. All right, now, organic means that it is living. And if it is inorganic, it is non-living, okay? So in other words, it never has lived. It doesn't mean it's dead. if I take, Indiana, have you got a piece of, just grab a piece of paper there for me?
Any piece.
Any piece of paper.
And if I mess up your notes, you aren't going to be angry with me.
No. Okay, people, this piece of paper comes from a tree. So, you know how we always say don't waste paper because it means a tree's going to be chopped down to make more. So always recycle. That's part of your next section of work, or at least module 3, strand 3, which is the whole environment. But if I look at this paper, you're going to say to me, man, that paper's dead. Yes, it is. It's dead because it came from a tree which was living. So it would be organic. So organic substances are substances that are living, or, okay, Indiana, I'm battling here with this.
Oh no, Kathy, do you know what?
Hang on, let's do this.
You're here for 3 hours today. By the end of the show, you're going to know exactly what's going on.
I don't know why I've got the, okay, organic, let's do it like this. And we're going to do just organic substances on its own. Otherwise, I promise you, I'm going to end up just talking. But we've got organic substances, they are living. Okay? Or they are dead. In other words, things that have died. Okay? Living, but in order to die, you must have lived. So it would be like this piece of paper comes from something that used to live, which is a tree. All right, so organic substances are living or dead. They always contain carbon. Now, you all did a little bit of chemistry in grade 8 and 9, and you would have learned at least the first 20 elements on the periodic table. So carbon is one of those elements. Every living thing on this planet contains carbon if it's living, and then clearly it can only die if it lived. If we look at, in contrast, inorganic substances, and I'm going to get another color here. If we look at inorganic substances, they will, and I'm going to put inorganic in blue, because I don't have enough space on the side there, but inorganic would be non-living. In other words, it has never, ever, ever lived. For example, the air around us, the oxygen, the nitrogen, all of these, carbon dioxide, these are all elements that have never, ever lived, and compounds that have never, ever lived. The air cannot live. Without air, the living things will die. Okay, which you are going to learn about later on when we talk about oxygen and the lack of oxygen in water, which then causes a process called eutrophication. So, inorganic, living or dead, organic, inorganic is non-living. Organic always contains carbon. Inorganic is just about every sub-element, which is what you'd find on the periodic table, every element known to man. And when we combine them, we end up with something like water, which is an inorganic compound. Why? It's inorganic, it's never going to live, but we have living things in the water. So this is something that's really important that you must understand when we look at the chemistry of life, is that everything on this planet that is living or dead always contains carbon. If it is inorganic, it is non-living, and it may be a single element or chemical, but it may also be a compound where we take hydrogen and oxygen and combine it to form water. Now, all of you will know, and I hope you will know, that we have water. And this is what a water molecule looks like, people. Your water molecule is always let's get a white here, H2O. Okay, what have we got two of here? We've got two little hydrogens and an oxygen. All right, so that gives me That gives me my H2O. And the H2O is a compound because I have two different types of atoms joined together to form a molecule. So you remember this from grade 9. You have atoms are the single little things, and when they combine with each other, they form molecules. Like, for example, and I can't think of one single one. Help me here.
Human being? No. An atom.
Give me an example. No, not an atom. An example of a compound. Carbon dioxide. There we go. So there we would have CO2. So we'd have a carbon atom and two oxygen atoms, and they would combine together to form a compound. Okay, so carbon dioxide. Hydrochloric acid is another one. That would be
now they're all coming out.
Cl. Yes. Now, people, those first 20 elements that you had to study in grade 8 and 9, you know what? Go get your old science textbook and just have a look at that so you can just refresh your mind on the atoms and the different combinations. That's not the science. It's just looking at the different combinations. So what do you have to remember now? Organic is living or dead, and it always contains carbon. And inorganic is non-living. It's never lived, but we need it to live. But it's non-living, and it's made up of different elements, which either are single or form compounds. Okay, so there's your water molecule. You must know H2O. All right.
It's almost as if you kind of know what the learners are thinking. I mean, we've got Afendule on Facebook helping out Tishwa Ari. I know, guys, I know I'm terrible at saying your name. I should actually go home and write.
What's that song? Say my name, say my name.
Exactly. And she said...
I'll stick to teaching.
Yeah, exactly.
Okay, not singing.
Leave the hard job to me, Kathy. Don't you worry. And what she said was, does an organic substance contain carbon? And then Afendule said yes. So obviously we're on the right track. Guys, please, we're on facebook.com/learnextra. My name's Indiana. This is Kathy. We are with you today. So please chat to us. Let us know if there's anything you don't understand. I'll stop Kathy.
Do you want to give me the address? Let me write it down quickly.
Yes, okay. So it's www. Get the pen.
Okay, pen.
www.facebook.com /
that way.
Yeah. Learn extra with an XTRA. Learn XTRA. And then, if you really want, for Twitter, we are with the handle, you know, the little at. You got to do the little at sign, at Learn Extra. That's definitely an at. They know what we mean, Kathy.
There we go.
Yeah.
Cool.
So guys, chat to us. We will help you. I will interrupt Kathy as politely as I possibly can and say to her, hey, somebody wants to know this. So get those questions in and let's carry on.
Cool. Now, people, you know how your mom has always said to you, eat your vegetables. If you don't eat your vegetables, you are not going to grow healthy and strong, and you need carrots to be able to see at night. And for those of you that are very athletic, when you get muscle cramps, what does your coach tell you? Tells you, listen, go and get slow mags. And slow mag is the tablets that contain lots and lots of potassium and magnesium. Why? Well, you think, that's where my body works. No, it goes a lot more than that. And when you go into a supermarket or you go into a chemist and you see all those health products and those supplements advertised, those supplements contain all the things you are supposed to be getting from the food you eat anyway, except that and this links to environment with monocultures. Come on, Indiana's heard about monocultures because we did this in the grade 12, guys, and prepping them for exams. You have everything just grows, and people just throw all kinds of fertilizers into the ground, and that messes everything up. It messes the balance up. But what actually ends up happening is that the vegetables and the fruit do not contain as much nutrients as we used to have. So eating a balanced diet becomes really, really, really difficult. So what is a balanced diet? And this you need to know for nutrition, but it's the chemistry of life. So here we go. This is it. Every single living organism on this planet, if it is living, all right, it's going to contain the following organic compounds.
Kathy, John's just let me know that we've had a caller, and the caller asked if organic nutrients are organic substances.
Well, a substance, yes, because it's a piece of matter. Okay, now we're going to take those different bits of matter and we're going to break them up so that you understand how they combine back into our body. Okay, just stay with me for 1 minute. All right, so here we go. Organic compounds. A compound, remember, is 2 or more elements that have gone together. So if we look here, we have now look at this word, carbohydrates. We have fats. Come on, should start ringing a bell now. We have carbohydrates, we have fats. We have proteins. Starting to make more sense now, guys and girls? Carbohydrates, fats, proteins, vitamins. Okay, DNA, RNA. So, what we call nucleic acids. Okay, this is what we have. So, if we look at carbohydrates, we have the elements, inorganic elements. Carbon, does it contain carbon? Yes, so it means it was made or is inside a living organism. So carbon, hydrogen, oxygen, that's carbohydrates. And you know what's special? Is that carbohydrates always have double the hydrogens to oxygen. So the hydrogen to oxygen ratio is always 2 to 1. So for every 2 hydrogens, there'll be an oxygen, or for every oxygen, there will be 2 hydrogens. Okay, but it contains carbon. Look at this. Fats. What do we have here? Carbon, hydrogen, and oxygen. You think, whoa, hold on. And you know, ladies, how we always say, a moment on the lips, a lifetime on the hips. Indiana?
I know that one.
Okay, do you know where that comes from? From here.
But not from our mothers.
Your carbohydrates can be converted into fats.
Yeah.
And your fats, when you exercise and you work really hard, can be converted back into carbohydrates.
Yeah.
So you eat too much, you don't exercise enough, the carbohydrates say, hold on a minute, let's convert to fats and get stuck in between what we call the adipose tissue. So it sits here. And if it really is bad, we get that, ladies,
the muffin top, that's what I call it.
We get that peach skin, at least orange skin, peel skin. And guys, you've looked at the girls when they're undressed on the beach and they're in their costumes. You know what we're talking about. Okay, so that is why. Because fats can be converted into carbohydrates. Carbohydrates can be converted into fats. All right? So if we look at this whole lot, we say, okay, we have got carbon, hydrogen, oxygen. The difference is here, hydrogen to oxygen ratio is always 2 to 1. But with fats, your hydrogen to oxygen ratio is greater than 2 to 1. So it will be 3 hydrogens to 1 oxygen. or 10 hydrogens to 2 oxygen, to 1 oxygen. Whatever the case is, that's what makes up our different fats. And why they're different? Because if it is a carbohydrate, your hydrogen to oxygen ratio is 2 to 1. And they love asking that in an exam. So make sure that you, if you listen now, you'll never have to learn it again because it'll be stuck in here. Then fats, also carbon, hydrogen, and oxygen, but your hydrogen to oxygen ratio is greater than 2 to 1. So you're going to have more hydrogens than double the oxygen number. And then proteins. Now proteins are special. They're carbon, hydrogen, oxygen, and nitrogen. And that is what makes proteins so different from carbohydrates and fats. But then you'll say, no, hold on a minute here. We have, come on, Indiana, I'm waiting for questions. Where are these winners?
Guys.
Start thinking. Listen. Proteins are carbon, hydrogen, oxygen, and nitrogen. That's what makes them so special. Carbohydrates and fats, very similar. You know, so what's the difference? A couple more hydrogens in your fats. All right. But proteins, they've got nitrogen. And that is why plants have to absorb nitrogen from the soil. Okay. They have to get their nitrates, nitrogen plus a whole bunch of oxygen, nitrates, from the soil to incorporate it to make the proteins which we eat when we eat plants. But whoa, we have to eat a lot of plants to get all the proteins that we need. But animals, your rabbits, your locusts, if you're into eating locusts,
I heard they're delicious. What are the Mampani worms? Mampani worms, delicious.
Yeah, but if you look at all the things that eat protein or plants, they take that plant protein and they convert the plant protein into the plant body, and then they take that, the horse, cow, donkey, chicken, sheep, all the things we eat is what I'm thinking of, will come along, plop, 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 and they go and they nosh the plants, and they now have proteins from the plants because they have enzymes and stomachs that can digest it. All right, so carbon, hydrogen, oxygen. Now you'll say to me, hold on. The only difference between carbohydrates, fats, and proteins is that fats have more hydrogens. They have the hydrogen to oxygen ratio is greater than 2 to 1. And for proteins, we have nitrogen. So what's the difference? They're all the same. No, they are not. Have a look at this. We say, okay, if I have a protein, I love life sciences, but you have a protein, okay?
I think the learners are loving it too.
Hydrogen, oxygen, and nitrogen. And we have carbs, or carbohydrates, carbs, and that is carbon, hydrogen, oxygen. But remember, hydrogen to oxygen ratio is 2 to 1. And then we have fats, and we have carbon, hydrogen, and oxygen. But your hydrogen to oxygen ratio, let me just see if I can take this up a little bit. Here is greater than 2 to 1. Okay, now fats are very, very light. They weigh less. You know what? People will tell you if you're dieting and you're really trying to lose weight, don't look at the scale. Measure your body because you can lose inches, so you've lost weight, but you may be training so you gain muscle. And muscle is heavier than fat. Why? Muscle is made of protein. So it makes muscle and protein. Protein is the most important thing in your body. Why? Because all cells, hormones, what have I done here?
Oh no, is it misbehaving?
Okay, I'm going to give that one a miss. I'm going to write here. All cells, hormones, antibodies and enzymes, which we're going to do a little bit later, hopefully, if we can get through everything. All of them are made of proteins. Okay, and proteins are sensitive to temperature. Proteins are sensitive to pH. So when the temperature is too hot, what happens to a protein? It denatures. And if it denatures, if I denatured you, come, Indiana, tell me.
Please don't denature me, because it sounds terrifying.
What do you think would happen? Would you be the same person you are?
No.
No, because I've denatured you. I've changed you.
Changed, yeah.
That's what denature means, people. So
never be a flower.
But when you denature a protein, you change its nature. So it no longer works like a protein.
Yeah.
You follow?
Yeah.
So, I mean, if you have, let me try and think, if you have a dress.
Yes.
And it's a lovely long dress, and you go and you cut it off over here and you turn it into a long shirt that you can wear with maybe ski pants, or you cut it off over here, or you can cut it off over here.
Or I can cut it and make it into a scarf.
Exactly, but you've changed its nature completely. All right, now thinking and remembering that analogy, all your cells, because your cell membrane is made of protein, your organelles are all made of protein, the nucleus is made of protein, the DNA is made of protein, so your cells are mainly made of protein.
Well, we've just got a question here. I think it has to do with proteins. Basically, nitrogen. Is nitrogen a protein? What? Nitrogen is in proteins, but is it a nutrient or a mineral?
Whoa. No, okay.
That's a big one. I'm sorry, Kathy. I love it when I throw it out.
No. The learners are confusing a nutrient, versus an element. All right. An element is helium. Was it helium, hydrogen, hydrogen, helium? I need a periodic table.
Yes. Would you like me to pull one up for you? I can.
Okay. But you've got the hydrogen and the helium. Then you've got carbon, hydrogen, oxygen, magnesium, all calcium, all those things. They are all elements. When you take two elements and you combine them, you end up with a compound. Okay. So an element is like those different letters that you used to have on the periodic table.
What I'll do
all
is,
those substances.
What do you think if I actually put paste a picture on the Facebook page of the periodic table? Would that help? So they know that those are elements?
Yes, it would be great.
So I'm going to put it on the Facebook page, guys, so you know that those are elements.
All right, people, so you are confusing this now. So listen, elements are what you had on the periodic table. So magnesium, calcium, phosphorus, potassium, hydrogen, chlorine, all of those are elements. Now you take those elements and you combine the elements. And when those elements join and they combine, they form molecules. Okay? Now, when they form, even if you take two elements and you combine them together, it forms a molecule. So any two atoms that join forms a molecule. But here we're taking different ones and we're putting them together. We then get a compound. A compound would be carbon dioxide, water, H2O, hydrogen chloride, okay, or hydrochloric acid.
Are you still asking me?
I actually can't think of any others. Okay, so then if we take two elements and we combine them and they are different or the same, we are forming a compound. Okay. I mean, if they're different, we form a compound. So we've now got compounds. Okay, so that's your thing about element or a compound. A nutrient would be anything that you are going to need in your body so that your body can function. So, what do we have? We have organic compounds. And that's where we were at now. So, organic compounds would be proteins, carbohydrates, fats. Those are all organic compounds. your nucleic acids, which you are going to do in grade 12, but you need to know about now, your DNA. Come on, if you've watched CSI, you know they talk about DNA, you know, the DNA test and who's the father, who's the mother, who's the murderer, whose blood is this, whose hair is this, DNA. Now, DNA is made of protein. Why? Because it's in the cell. All right, so DNA is essential for us to live and be the way we are. But where every time you eat an apple or an egg or a piece of toast, okay, in there, you are going to find nutrients, and those nutrients are made up of these organic compounds. Why? They come from living things. Anything that is living and now has died will be organic, and it will contain proteins, carbohydrates, fats, and vitamins. All right, so please make sure that you understand the difference between an element, okay,
Yes.
and an atom versus a molecule. And a compound will always be two or more elements that have combined. All right.
Okay, so I
Does
hope
that
you
make
guys,
sense?
I hope you guys understand. I know that Matariana said, how can it be in our DNA? Maybe we can quickly answer that again, just maybe in a little bit more detail, and then we'll go to an ad break.
Okay.
Yeah.
Listen, hun, what was the name?
I think it was, I hope I'm saying it right, Matariana.
Matariana, listen carefully, sweet pea. In your nucleus of your cell, okay, do you remember nuclei? Okay, now in the nucleus, you did that in grade 8 or I think grade 8, if I remember correctly, you do a nucleus. And in that nucleus, you have the chromatin network. And that is where your DNA is. And on your DNA, the actual DNA strands are made up of little structures called nucleotides. And a nucleotide, I actually need 5 of these in a row. If you look at a nucleotide, and here we go again, I'm not sure, I think my nails are too long. A nucleotide, and I'm going to do this quick. This is a building block of a DNA. So what are we going to have? We're going to have a phosphate. We're going to have a pentose sugar, which is a 5-sided sugar. So this is a C5 sugar, all right? And then we have here, and this is where our protein is. This thing here is called a nitrogenous base. Now, if you look at this word, you're going to do this in matric in detail, but you need to know it now anyway. If you look at it, nitrogen, which tells you it's got the nitrogen, but it's a nitrogenous base. In other words, it's a base that's made up mainly of nitrogen. This is where your protein part of your DNA is. Now, DNA will be a double strand, so you'll have a phosphate and a pentose sugar there, and you'll have the other half of the nitrogenous base joining on there. So very, very quickly, very, very basically, that is what you have, and that's where the protein sits. In your DNA, which makes up your chromosomes, and you know that you are your chromosomes. 23 pairs in this body. And if you're female, XX, and if you're male, XY chromosomes are there as well. They are 2 of your 23 pairs. Or at least they are 1 of your 23 pairs of chromosomes. So people, please make sure that you understand proteins, and that we're going to have those proteins in all. They make up our cells. So all cells are made up of proteins. All your hormones, except your sex hormones. You'll say, because you're grade 10 and your hormones are all going mad, and everybody keeps telling you that. Well, those hormones, those same hormones are chemical messengers, and they tell your organs what to do. So your organs are not going to do anything unless a hormone says, oi, you need to do this, you need to release that, you need to start fixing this, what. That's what your hormones do. They're chemical messengers. And hormones, all of them are made of protein and fat, some just protein, but your sex hormones, and Indy, the kids need to know this for grade 12 as well.
Even though they're probably laughing and tittering. You go ahead. You go, Kathy. I'm the one that gets all embarrassed and shy, and then Kathy's like, oh, nonsense.
But your sex hormones, your estrogen in us girls, progesterone in us girls and testosterone in the guys. That's what makes them all full of nonsense, especially in grade 10 and 11, okay, and all cocky and I'm bigger and better and what. It's those hormones. Okay, so testosterone in males, estrogen and progesterone in females, those are the sex hormones. They are only made of fat. So when a person loses a lot of weight, like for example a girl or guys that become anorexic, especially for girls, they will stop menstruating, they'll stop their periods because there is no fat to make the estrogen and the progesterone.
Totally. Kathy, we're going to a break. I'm going to ask the producer going to come in here and grab us out of here and be like, come on. But guys, I know a lot of you grade 10s are saying that you're learning about this today. Who actually said that? I think, was it Christina, was it Lawrence? It was one of you. You said that you're learning about this. So guys, quick short ad break and we'll be back. See you then. Hi guys, and welcome back to grade 10 Life Sciences. Hope you're all watching and hope you're all enjoying our show. Get your questions in, let us know what you're not understanding. Let me know what I can ask Kathy. It's facebook.com/learnextra. Also join us on Twitter @learnextra. We've got quite a few questions, and I know Kathy was running through the last question before we finished. Kathy, how's about you just carry on with the question and I'll just kind of come in between.
Indy did say that there was a question on inorganics. I'm getting to that. And what we're going to do is we'll be putting tables on for you on the organic compounds and the inorganic compounds that you have to learn. Make sure you learn them well. Take those tables, print them out, write them out. Better yet than printing them out, stick them up behind the toilet door, stick them up on the fridge, stick them up next to you where you bath, and make sure you read them at least twice a day. Okay, so you must know them. They are good, easy marks. All right, people, so let's get back here. Proteins, all cells, hormones, antibodies come back here. Hormones, antibodies, and enzymes are made of proteins. Okay, so they are essential. No antibodies, you have the equivalent to HIV and you die. Okay, enzymes, every catabolic building and anabolic breaking down process, at least every anabolic building and catabolic breaking down process in your body is controlled by enzymes. So look at this. Your cells, everything about you is cells. Your hormones tells the cells what to do. Your antibodies protects the cells. Your enzymes, well, hello, everything works. It's not just your digestive system. Everything works with anabolic building and catabolic breaking down processes in your body. So very important, and guess what? They all are made of proteins. They all contain carbon, hydrogen, oxygen, and nitrogen, and something else. If we take a protein, and proteins are big, they're macromolecules, and we break them down, we can break it down, break the nitrogen off, that becomes a substance called urea, which you urinate out of your body in your urine, okay? And the carbons, hydrogens, and oxygens are grouped together so that the hydrogen to oxygen ratio becomes 2:1, and we convert the proteins into carbohydrates. That is why you can survive on a protein-rich diet, okay? Just protein. Why? Because your body will break the protein down. Your body cannot use protein. Proteins are made up of 20 different amino acids. Your body cannot use and break those or use the amino acids for energy. It can only use glucose. And your carbs, hydrogen to oxygen ratio 2:1, your carbohydrates are divided into your monosaccharides, 1. Disaccharides, those are your building blocks, so 2 of them die. And then we have polysaccharides, which is many, which is, for example, your starch. So monosaccharides, we have glucose, we have fructose, and we have galactose. So your carbs, and I'm going to write fast, you're going to have to follow. You have your mono, means 1. Monosaccharides. Those are your monomers. And they are your basic building blocks. Then we have our di means 2. It will be 2 monosaccharides. So you'll have a mono plus a mono. Okay? And then you have your poly, which is going to be many. And an example would be starch. Okay? So if we look at our monosaccharides, it's glucose. That's the lovely stuff. It's really lacquer stuff. Sugar. Okay, sugar. Anybody like sweets? Glucose.
I do.
Okay, who doesn't? Okay, so glucose. We have fructose, which is from fruit sugar, but it's still a monosaccharide. And we have galactose. Now, come on, people, use your common sense. If somebody's lactose intolerant, they don't like milk too much. Okay?
And their bodies don't like milk at all.
Their bodies don't like milk at all, right. The lactose is a disaccharide, but it's made from at least from glucose, 2 monosaccharides, glucose and galactose makes lactose. So your disaccharides, you're going to have maltose, which is going to be a glucose plus a glucose. Okay? You have sucrose, which is the wonderful sweet stuff. That's a glucose plus a fructose. And then your lactose, which is milk sugar, is going to be your glucose plus your galactose. All right, so a disaccharide is a monosaccharide plus a monosaccharide. You must know your monosaccharides. They are the monomers of your carbohydrates. Lots of glucose gives you starch. Okay, now, your fats, people, look here. The body can't store proteins, and your body can't store carbohydrates. What your body can store is fats. Fats are light, they're easy, they have less oxygens to hydrogens, and they're easy to store. So, if you look, so you can take your proteins, they'll be broken down into carbohydrates, into glucose. That will give you energy, and the nitrogen becomes urea. The liver does that job. Then, if you don't use those carbs, they get converted to glycogen. Starch is a polysaccharide in plants, and water doesn't affect it. Okay, it's osmotically inactive. Whereas if we look at in humans, we don't have starch in our bodies. We eat starch. But we store our glucose as a substance called glycogen, which is in the muscles. And it is also insoluble to water, so it is osmotically inactive. It doesn't affect the water.
Kathy,
right. Yes.
Are fats monosaccharides?
No, sweet peas. Listen. Whoa. Okay, look here. Carbohydrates, okay, organic compound. Carbohydrates, the monomers, are monosaccharides. Okay, monosaccharides, there are 3. You have glucose, you have fructose, and you have galactose. Glucose is in everything, fructose is in fruit sugar mainly, and galactose is in milk products, milk sugar. Okay, those are monosaccharides. Now, carbs, you have di, okay, so di means 2, mono means 1. So disaccharides, you're going to have a monosaccharide plus a monosaccharide. And that's what I've just done. Glucose plus fructose is sucrose. Glucose plus glucose, maltose. And glucose and galactose, milk sugar, which is lactose. So those are your disaccharides. And then falling under carbs as well, if we have lots and lots of monosaccharides, we have what we call poly. Poly means many, so polysaccharides. And poly, remember, is many. So we've got lots and lots of glucose. So in plants, the polysaccharide, which is a carbohydrate, will be starch. And in animals, and that includes us humans, by the way, animals, we are going to have glycogen. Okay, and this ogen, if you see O-G-E-N, in any word, it means it's insoluble. It can't affect the water. Okay, so that's there. Then you have fats. Now, fats have their basic building blocks too. Remember, they've got the elements, carbon, hydrogen, oxygen, where your hydrogen to oxygen ratio is greater than 2 to 1. That's what makes them so nice and light. So when you lose weight and you're doing exercise, you actually gain muscle, which is heavier than the fat, so you'll gain weight, but you'll lose inches. Okay, so that's where the sense comes in, that one. So fats, your monomers, and I think that's where the learners are confused. They're getting confused between a monomer, Indiana,
yes,
and a monosaccharide. If it's got saccharide on it, it means a sugar. Okay, that's what saccharide means. But if we look, monomers of fats, your basic building blocks of a fat is going to be 3 fatty acids, so that's easy to remember because look, it's fat. So 3 fatty acids plus 1. Now, this was glycogen, so it's going to be 1 glycerol. And you see that OL tells you that it's got, if you're doing chemistry, it'll tell you it's got an alcohol on it. But you don't need to know the actual chemical formulas. All right, so your fats, carbon, hydrogen, oxygen are your elements. Hydrogen to oxygen ratio is 2 to 1, and your monomers are 3 fatty acids and 1 glycerol. So that's how a fat is made. And then lastly, we have our proteins. And a protein, okay, well, get nucleic acids as well, which I've done, but proteins, here you have the elements are carbon, hydrogen, oxygen, and nitrogen. And you know what? Some proteins are special, and they will have sulfur, some of them will have phosphate, okay? But that's only some of them. But every single one of them will have carbon, hydrogen, oxygen, and nitrogen.
Kathy,
Okay, yes.
we've got Sandile. He said, what are the functions of proteins? And this is what you're about to go through, right? So, Sandile, hope you're watching. This one is for you and all the rest of the grade 10s. We've got about 5 minutes left, guys, to get those questions in. Also, grade 10s, you know what? Watch the grade 11 show. Kathy and I are both on, you know what? Even watch the grade 12 show. Carry on, Kathy, because we're here
and
till
make sure
6.
you go on to the Learn website and make sure that you download X sheets because the summary sets will be there for you. All right, so carbon, hydrogen, and oxygen. So what is and they're big, they are macro, they're huge molecules. What are the functions of a protein? We've just done this. Sandile? All cells, all hormones, all antibodies, and all enzymes are made of proteins. That's number 1. Number 2, all reactions, all functions in a cell are controlled by the nucleus, which is made of proteins, people. Proteins are sensitive to temperature and they're sensitive to pH. So if a protein gets too hot, it's going to break down. It's going to denature. Do you remember just now we were talking about denature? Take a long dress and cut it into a short top like this, you have denatured that dress, haven't you? Okay, so that's what denaturing is. It loses its ability to work as a dress anyway if you've cut it.
Yeah.
Right? If it's too cold, it becomes inactive. Now people, what's important here is if a protein's inactive, you haven't denatured it, you haven't destroyed it, but it's having a good sleep. It's inactive.
Would it be the same? I don't know. Maybe I'm wrong. Mindset is, I hope not. Else I'm going to make a very silly person of myself. When you, with fruits or a vegetable, when you freeze it or when Is that the same kind of thing? Like when you denature, maybe when you boil it for too long and it loses its
When
nutrients?
you boil it, what do they tell you? All the nutrients are sitting in the water. Okay, cool. But, so you've denatured it. When you boil an egg, or you fry an egg, the white of the egg, it congeals, it coagulates, it goes white. All right. You've denatured it.
Yeah,
all right.
Total.
So
I understand.
You're happy with that?
You guys,
okay.
if I understand, you better understand
but
too.
I can take meat, I can take vegetables, I can make the most amazing soup, and I can stick it in the deep freeze and freeze it for 3 months, and thaw it. All the nutrients are still there, people. So when you freeze a protein, it becomes inactive when it gets too cold. It becomes and that is why we have, you know, when people get very cold and they're caught in a snowstorm,
yes,
they become hypothermic. All right, why? Everything shuts down and they say keep walking, and you think no, all I want to do is lie down and sleep. Because your body's using the little bit of energy it's got left to charge your heart and your brain and your lungs. Okay, so that's what you end up with. You can cool a protein down, it becomes inactive. You overheat it, it becomes denatured. All right, so, and sensitivity to pH. If you take a protein and you put it in the wrong pH, it stops working. And that is important for when we look at enzymes. Because remember, enzymes are made of proteins. And if an enzyme is too hot or too cold, too hot, it will denature. Too cold, it becomes inactive. If the pH is wrong, it denatures that poor enzyme completely and it can't function. Okay, if it's denatured, it cannot work. It's like me taking you and chopping your arms and your legs off and expecting you to run 100 meters. You can't. It's impossible. I've changed your nature, your ability to work. Okay, so your proteins, the monomers or basic building blocks of a protein are called amino acids. Okay, and there are 20 known amino acids in nature, and all our proteins are combinations of those amino acids, and it's those amino acids that make up specific proteins in our body. So Indiana, you and I have the same 20 amino acids as John or Colleen or Belinda or whoever, but it's the combination of those proteins, and it's the same as us. Both Indiana and I are girls. We're both female.
It's true.
We both have 10 fingers and 10 toes and 2 arms and 2 legs and 2 eyes and a nose and a mouth. But do we look identical? No, we don't. Why? Our body's been put together as an individual. Same with Indiana. But we're made up of the same stuff. So your organic compounds, carbohydrates, fats, lipids, fats or lipids and proteins, your nucleic acids, which make up your DNA in your nucleus, which is what you are and why you are what you are, and your vitamins. Why? Vitamins come from where? They are made by plants. Okay, so they are created by something that is living. They immediately become an organic compound. Does it make sense?
Makes total sense. I love this show. Thank you so much, Kathy.
Pleasure.
Do you know what?
Are there any other things there that we can quickly go? I think we've got like 10 seconds.
We've literally got 0 seconds.
Okay.
So guys, I'm really, really, really sorry. But we will try and answer some of your questions on the page during the break. But we have come to the end of our grade 10 Life Science show. Please make sure that you join in next week because we're back, same time, same place. Bye, guys.
And cheers, everybody.
Wait.
And please check the Mindset website because we are going to put stuff on there for you, all right?
Yes. No, we definitely will. I'll make sure that I put all the links and I put everything down. Guys, grade 11s, please get back to us. Well, we're starting now, next. See you then, grade 11s, and see you later to grade 12s. Bye.